Hey everyone, and welcome back. Today we're going on an incredible journey through space and time, all the way back to the beginning of everything. We are going to talk about something super cool and a little bit mind-boggling called Webb's paradox. It sounds like a secret code from a spy movie, right? But don't worry, I'm going to break it down so it's super easy to understand. Imagine the universe is like a giant cosmic history book. We believe this book started being written about 13.8 billion years ago in a massive event called the Big Bang. Think of the Big Bang as the once upon a time, on the very first page of our universe. Since then, the universe has been getting bigger and bigger, like a balloon that's constantly being inflated. All the stars, galaxies, and planets, including our own Earth, are like the words and pictures filling up the pages of this book as time goes on. Now, how do we read this cosmic history book? We use amazing tools called telescopes. When we look at a star in the night sky, the light from that star has traveled a very, very long way to reach our eyes. It takes time for light to travel. So when we look at a star that's far away, we're not seeing it as it is right now. We're actually seeing it as it was in the past. It's like getting a letter in the mail that was sent a long time ago. The farther away we look into space, the further back in time we see. It's a real-life time machine. Astronomers have built incredibly powerful telescopes to peek at the earliest chapters of our universe's history book. The most powerful one we have right now is the James Webb Space Telescope, or JWST for short. This telescope is like a super-powered magnifying glass for looking at the oldest, most distant things in the universe. Its mission is to see the very first stars and galaxies that ever formed, the first twinkles of light after the Big Bang. So scientists expected that when they pointed the Webb telescope at the most distant parts of the universe, they would see baby galaxies. Imagine seeing a picture of your grandpa when he was just a little kid. You'd expect him to look young, small, and not fully developed, right? That's what scientists thought they'd find. Small, messy, and simple-looking baby galaxies. These would be the first galaxies just starting to form, not long after the Big Bang. But here's where things get weird and exciting. When the Webb telescope sent back its first pictures from the dawn of time, astronomers were shocked. Instead of finding tiny baby galaxies, they found galaxies that looked surprisingly old. They were big, bright, and well-formed. It was like opening a photo album expecting to see a newborn baby. But instead, you find a picture of a teenager who already knows how to drive. These galaxies seem to be much more mature than they should have been for their age. They were packed with stars and had complex shapes, things that scientists thought took billions of years to develop. Yet here they were, existing only a few 100 million years after the Big Bang. That's like building a giant, detailed Lego castle in just 5 minutes. It just doesn't seem possible. This is the heart of what people are calling Webb's paradox. The paradox, or the puzzle, is this. How can these ancient galaxies look so old when the universe itself was still so young? It's like finding a tree in your backyard that's 100 years old, but you only planted the seed 10 years ago. It just doesn't add up. So, what could be going on? Scientists are scratching their heads and have come up with a few ideas. Let's explore them. One idea is that maybe our understanding of how galaxies grow is wrong. Perhaps galaxies can form and grow up much, much faster than we ever imagined. Think about it like baking a cake. We have a recipe that says it should take an hour to bake. But what if there's a secret ingredient or a different oven temperature that could bake the cake perfectly in just 10 minutes? Maybe the early universe had some kind of secret ingredient that allowed galaxies to assemble themselves at super speed. Perhaps the gas and dust needed to form stars came together much more efficiently in the early days. Another possibility, and this one is a real mind-bender, is that maybe our measurement of the universe's age is slightly off. Remember how we said the universe is about 13.8 billion years old? That number comes from a lot of complicated measurements and calculations, based on how fast the universe is expanding. But what if the universe is actually older than we think? Imagine you thought a movie was 2 hours long, but it was actually 3 hours long. If you walked in during what you thought was the beginning, you might be confused by how developed the story already is. If the universe is, say, 26 billion years old instead of 13.8 billion, then these galaxies would have had much more time to grow and mature. They wouldn't be teenagers, they'd be adults, and their appearance would make perfect sense. This idea challenges one of the most fundamental things we think we know about the cosmos, so it's a very big deal. A third idea is that maybe the very laws of physics were different in the early universe. The rules that govern how stars form and how gravity works today might have been slightly tweaked back then, allowing for this rapid development. It's like playing a video game where the rules and power-ups in the first level are completely different from the later levels. We are only just now getting a glimpse of that first level, and we might have to relearn the rules. So which one is it? A faster recipe for making galaxies? A different age for the universe? Or different rules of physics? The honest answer is, we don't know yet. And that's what makes science so exciting. A paradox like this isn't a problem, it's an opportunity. It tells us that there's something new and amazing to discover. It's like finding a secret locked door in a castle you thought you knew completely. We don't know what's behind it, but we're dying to find the key. The James Webb Space Telescope is that key. It will continue to look deeper into space, gathering more data and more pictures of these ancient galaxies. Each new image is another clue in this cosmic detective story. Scientists will study the light from these galaxies to figure out what kinds of stars are in them and how old those stars really are. They will look for even older galaxies to see if this trend continues. This is how science works. We have a theory, we make a prediction, and then we test it with an experiment. When the experiment gives us a surprising result, we don't just give up. We get excited. It means our old theory needs to be updated or maybe even replaced with a brand new one that better explains what we see. So Webb's paradox isn't a sign that our science is broken. It's a sign that we're on the verge of a huge breakthrough in understanding our universe. We are living in a time where we are actively rewriting the first chapter of the cosmic history book. What we thought were the first scribbles might actually be beautiful, fully formed sentences. And you get to watch it all happen. By the time you're an adult, the answer to this puzzle might be in your science textbooks. You can tell people, I remember when scientists were first discovering this. It's a thrilling time to be curious about the universe. So, to sum it all up, Webb's paradox is the puzzle of finding surprisingly mature, old-looking galaxies in the very young, early universe. It challenges our ideas about how fast galaxies can grow, or even how old the universe is. But it is a wonderful puzzle that will lead to incredible new discoveries about where everything came from. What do you think is the answer? Do galaxies just grow super fast, or is the universe older than we think? Let me know your theories down in the comments. It's fun to guess and imagine. Thanks so much for joining me on this cosmic adventure today. If you enjoyed this journey back in time and want to explore more amazing mysteries of the universe, make sure to hit that like button and subscribe to the channel so you don't miss our next video. Stay curious, and I'll see you next time.